Hello and welcome to the video for IPsec. This is the basic topology that we're going to work on. One end we've got a 10 dot network connected to router R1, and at the other end we have a 172 dot network connected to router R2, which is separated from each other by a public IP. You can consider that to be an ISP. There are 5 basic steps to configure crypto over on your routers, which now we would go one after another. First thing is, what you try to do is, if your router supports crypto or not, you just try to type a crypto command. If it's taken, well and good, you're good. So let me look at what interfaces I have connected here. So you can see a 20.20.2, and on the router 1 you have 20.20.1 connected to each other, and a 10 dot network on one side of the LAN and 172 on the other. Okay, let's get going. So we go to the first step of configuring an IPsec VPN is the icmp or the IKE phase 1. So what we're going to do is we're going to it's crypto icmp policy. We create a policy, and then we decide what a password we're going to use. So we're going to say it's going to be a pre-shared. Pre-shared means we're going to define same password at both the ends, on router 1 as well as routers 2, so that they can authenticate against each other. These are the basic 2 steps. If you do not, you can get the hash defined here, or if you just define the policy and the authentication method, that's good enough. The rest of the configuration would be by default. So I have defined hash here, so I have to define hash as SHA on the other router as well. Okay, so now the next step here is to go to define the key. Crypto icmp key. So we got to have a good key, but in the example I'm just going to use Cisco. So what address is I'm going to work on? The address that I'm trying to create a tunnel is on the other end, so it is 20.20.20.2. so crypto icmp key Cisco address, you got to write the parent IP address. So this is the part 2. First we define the policy, next we give the password. Now we come to define, this is the first phase. So now we come to defining the IPsec, the part 2 of it. So crypto IPsec, we create a transform set. I'll give it a name, my set, the best use anywhere else. ESP SHA has, there are various authentication methods on this one, so you can select any one you like, but make sure that both the ends, whichever you're trying to pair up, has the same configuration and authentication as well. Yes. Okay. Here there would take a default mode as tunnel mode. There are 2 modes, you got tunnel mode and transport mode. This one's a tunnel mode. Okay, we've created a policy, we defined a policy, we've pre-shared key we've defined, and now we've defined the IPsec transform set. Now we're going to create an access list. That's the third phase, the access list. So we would want, on this router, we would want everything from this to reach here. So access list 101, I will permit IP 10.10.10.0 0.0.0.255 and to reach 172.16.10.0. okay, to reach 172.16.10.0 0.0.0.255. okay, I've created an access list. So this would define what traffic would be encrypted when I pass from one end to the another. So this is access list here. So I would come to the fourth stage of configuration. So now I would create a crypto map. I'll give it a name. So router 1. okay, let's make it R1 to R2, a short name, so that I don't make any mistakes here. I'll give it a number here. What kind of crypto map is that? IPsec Icmp. okay, you get a message here. It will not be enabled till you define a peer. So set peer. What is the peer IP? This is the peer IP here, the other end till where you want to create a tunnel. So set peer 20.20.20.2 and then match address. So match address 101. So 101 is the access list. So this crypto map is a name, and we're going to define a peer. We're going to follow that access list rule, whatever has been defined, and set transform set my set. okay, so since we have now created a crypto map, we need to apply that on the interface that would be going to the other end. That's the outgoing interface here. So I would go to 0/0 on router 1 and apply the crypto map. So it is in the serial 0/0 crypto map. What's the name? This is the name here, R1 R2. okay, so you can see here crypto Icmp is on. So we are all set defining the Icmp on router 1. okay, you can see that since we had only configured on one end, you're still seeing it down. You have configured it good, so you can check it like so crypto sessions, so crypto Icmp SA. You don't see anything here since we have not configured from the peer end. So let's go to router 2, and I would configure the same here. I will go to first define Icmp crypto Icmp policy 1. okay, what do you want to do? Authentication is pre-shared. okay, I had defined hash at the other end, SHA, so I'm going to define the same thing here. If you don't define at both ends, it's okay. It's going to take as whatever is the default. okay, I'm going to come back here. So now the next one is the pre-share key. Repeat here, the crypto Icmp key. So I put Cisco as the key. So here the only difference is when you go to router here, router 1, when you see crypto Icmp Cisco address 20.20.22, because we are trying to put the address, the peer address. So when I come to router 2, so it's going to be 20.20.20.1. that's the peer end address. What did I miss? Okay, I put a plural addresses. I don't want that much. Okay, so that's good. So now we've defined Icmp or the IK phase 1. So I'll go to phase 2, crypto IPsec transform set. Let's give it a my set. So I'll have to provide in the same authentication methods here. Whatever I type at the other parent, I'll have to give it the same. Okay, that's cool enough. I have defined that as well here. So the next here, I'll create an access list 101. So in this case, I would create an access list from here, anything from here to reach here. So access list 172.10.16 16.10.0 000 wildcard to reach 10.10.10.0 0.0.0.255. Is it 10.10.10.0? Okay, I missed something here. What do I want to do with this? I want to permit IP from this range to that range. Okay. I missed it here. So it should be 101. Okay. They should fix it. Okay. Now since we've created access list as well, so now I would want to create a crypto map. Crypto 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 map. Router 2 to router 1. Okay, 10. Just a number, I just identifying each rule by the number. It's so same thing here. Set peer is, what's the peer here? Here, this is the peer. Set transform set my set. So this transform set my set is the set from here, in case you're wondering from where I got that. Okay, match address is this here. Okay, the address for the access list, that's done. And the final phase is to apply this crypto map on the interface. So here on the router to the same serial 0/0, I would apply to a serial /0. So I would config the interface serial 0/0 c crypto CRYP crypto map. The names R2 to R1. So we are done here. So we can see Icmp is on. So let's check. So crypto sessions, I still see it down. I would try to reach here first. Okay, so I should be able to reach there from the LAN. What's the LAN IP address on router 2? 172.16.10.1. 172.16.10.1. Okay, that's good. Let's try to come to router 1 now. Let's see what we have here. It's still down. Okay, let's try to check if I can ping here. I should be able to ping from the source. So what's the source here? The source here is the fast Ethernet. Okay, so crypto ISA KMPSA. it's still not established. So let's me go back and check the configuration. So crypto icmp policy 1 pre-shared key cisco 2020-22. I will check here. Sometimes it takes a minute or two for that tunnel to come up. So by that time, let's make sure that our configuration is good. Crypto icmp policy 1 authentication pre-share crypto icmp cisco address. That's good. Okay. Crypto IPsec transform set my set. This is the ESP-AES. Okay, the same thing here. Crypto map IPsec set pure 2020-21 set transform set my set. Okay, transform set my set. Okay, I also see a crypto map applied here. The access list 10 okay, that's anything from 10 network 0.255 should be able to reach 172.16.10.0s. okay, let's check again. Ping 172.16.10.1. okay, now it's pingable. So crypto, okay, ISAKMPSA. I'm still not so crypto sessions. I still seeing it down, though I'm seeing sessions down, though I'm able to reach that end. Let me go to my VMware machine where I have configured 172.16.10.50, 172.16.10.1. From this machine, I should be able to reach the 10.IP, 10.10, 10.10.10.1. Okay, host not reachable. I should be able to. To IPsec. So crypto ISAKMPSA. Still not so crypto sessions. I don't know why it's still showing it down. IPsec flow 172 16.10.0 to 10.10.10.0. Everything's good. Active SS0 origin crypto map. I put a crypto map on the serial, so let's run run serial interface. Okay, router 2 to router 1, IP address 22.02. Let me give a continuous ping 172.16. No, I should be able to reach 10 ping 10.10.10.1. Repeat count 100. Okay, I mixed Cisco and Juniper commands. Source fast Ethernet. So my source is F0 was now fast Ethernet 1/0. I'm trying to create an interesting traffic. Okay, now it's working. What I've done is I created interesting traffic. Since there were no traffic on passing on through that tunnel, it was not coming up. So crypto sessions. Okay, now you see that crypto sessions is up. So crypto ISA KMPSA, you can see what's up here. So crypto ISA KMPSA. Another thing, basic commands for crypto the next phase IPsec. So it's gonna it's gonna show you everything here from what on which interface it's configured. It's gonna show how many packets. So it's a 199 packet in and out. So since I've given a repeat of 100, so what I can do here is I can give an extended ping. Okay, I will increase the ping here, repeat count 100. So that was 199, so it's going to be 299 here. If you increase there, so you can see 199 here, it should be 299 here. I'm lazy, I'll just type the command. So crypto IPsec SA. Okay, see this? Okay, now that was it. So thank you for viewing, and I hope this video will be helpful to you. Thank you very much.